Hey guys, it's Simon and welcome back to another video about the Fleks entity component system, where I'm currently working on the Kotlin multi-platform part, which works good so far. So first of all, the guy who helped creating the first version of this branch did a great job, and now I made a poll a few weeks ago where I asked if we should go for annotation processing or if we want to go a declarative route with a custom DSL to define the world configuration. And yeah, people now voted for the DSL part, which I also think is fine, because it describes that in a very easy way how the world is configured, and also there will be no magic in the background, so the learning curve also in general will be quite low. And I have now a first draft available, but I also have a few questions where we might discuss that. So first of all, so how does it look like? So when you create a world, you can still define the entity capacity at the beginning. So that is unchanged, but those two things are now new. So first of all, there is a components block where you can add now the different components to the world, and also a listener of a component. So if you want to react when a specific component, in that case the render component, gets added to an entity and you want to react on that, then you can define that like this with a custom listener, which is an optional parameter. Also this thing here, so this double colon, it's just a short version for the constructor call of this component without an argument, because what add is doing, it's simply you need to define how is your component getting created. So usually I think that's always the same. A component should not have any arguments, so it should always be a no args constructor, which can be done with simple data classes when you define some default values for the properties that you have in your class. So that is then a short version, and with that you define the components that describe or that you can use in your world. In the background, this will then still create this component mapper objects that I come to in a moment. Yeah. Then the second part are the systems that you want to add, and there it's now also not happening anymore with dependency injection, also no reflection magic. You're really creating the instance of your system yourself, and there's a helper function, which is the mapper. So if your system requires a specific mapper, like in this case, I need to, for example, the position component mapper, then within the configuration, so within that block here, you can have the access to the mapper function, which simply returns the mapper of that specific type. So that would be an easy way to get the mapper that you have defined up there. The advantage of that approach is, again, as mentioned, it's pretty straightforward. So everybody who will see that code will understand it. There is no magic happening in the background. And also, if you would use multiple worlds in your application, so for example, for me a use case would be in an libgdx game, and I have a menu screen where I maybe have a simplified world where I don't need all of the components and not all of the systems. And then the main application, the game, for example, with another world with different components and so on. So with that way, you can really define exactly what kind of things are used in your world, and everything else that is not configured will not be part of that specific world. The downside, of course, there's of course downsides. What I personally don't like a lot is that I need to add my components. So would be great when defining the data class like this would be already sufficient that I can use it everywhere. But unfortunately, with the multi-platform approach, I don't see an option there right now, because the reason is when let me share you some or show you something. So the reason is we have now different backends. So there's a common project, so the common main, which contains general Kotlin code, which will then be compiled to different backends. So for the browser, it will be a JavaScript backend. For the JVM, it will be the JVM bytecode stuff. And there would be also a native backend, which also should work already, but I don't need any custom code for that. So for native applications for Linux and Windows. So that is the main advantage of all of that. But the downside is that, of course, in the common code, I don't have access, of course, to Java reflection, because that would be specific to the JVM backend and is not available in the common code, so I cannot use any reflection in there. Also, another thing which I do not like a lot, but I cannot change that, is there's also methods missing, like, for example, find annotations, so that I would get out the annotations of a class. So that's also not possible in the common code. I could maybe add, but I did not check that, I could maybe add the Kotlin reflection library as a dependency, but I don't want that because it's very big. I think it's 2.5 megabyte as a dependency, and that would be then, especially for backends like, for example, Android, which would also be a part of those backends. There we would then always have at least 2.5 megabyte already for reflection part for the Kotlin library. And right now Fleks is only, I think, 78 kilobytes. So I want to keep it small. And yeah, I think also some reflection stuff even does not work because that's not available. For example, on a JavaScript backend, there are certain things simply not available on the native backend. So we cannot rely on that. So these are the downsides, but I think the advantage is also for the future. The multi-platform approach would be the correct way. And as always, this is just the first draft and first version, so could be improved, of course, in the future. And yeah, I tried it now out a little bit, so played a little bit around and made here a little playground. So everything is still working. So I have one system, which is this one, which simply prints out that the interval system gets triggered or is ticked with the 3 update calls here below. And then I have an iterating system with a specific configuration for entities, and there I also see that it still prints that out, and also this mapper function here provides the correct mapper to this system. Also, I added now like a family creation DSL as well, because when you create an iterating system where you want to iterate over specific configuration of entities, then that could be done like that. And here is all my first question to you guys: what do we prefer? So do we prefer to provide the family here directly as a constructor argument? So it will always look like this. I personally don't like that a lot, but it also works like that in the Ashley component system, so maybe people are used to that. Another approach that I could think of is that when you implement an iterating system, that you simply have to provide, for example, we could call that family config or family method or whatever, and in there you then simply return that block here. So could be even simpler written, so could be like that, for example, and that we have it then like this. So it will not be part here of the constructor. Here we would then remove it. It would be then a separate method where you define that. That would be my second approach, and currently I'm tending more towards that solution, but please let me know in the comments what you think, which version you prefer. Do you prefer that one, so a function that you need to override, or do you find it better or easier to use when you define the family here as a constructor argument? And the second question that I have is, as you see here, I removed the dependency injection part completely. So you really create the systems now on your own, and you pass already everything in that you want to have in your systems. Dependency injection would work. So the current Kotlin multi-platform branch from the guy who helped me on GitHub supports that. But from what I saw, I think it has a limitation. So again, your system must have no argument constructor. So you could pass a system like that. And then in your system, directly, you could have here then your things. So for example, mapper1, and then you need to write something like inject mapper, or for example, you need to have access to, I don't know, a tiled map, for example. Then you need to write something like this. And this injector object contains all the injectables that you add to the world configuration. And then when you assign it to your properties, then you will simply get that. So you would need to define then your things like that. It does not work like we had it before. So in the JVM branch or JVM version of Fleks currently, you could write something like this. I don't know, this is for example the component mapper of something, some component, and this is for example a tiled map, and it worked like this. So then with reflection magic on the JVM backend that we could use, it would simply or analyze everything and pass in the correct types that you add there. But with Kotlin multi-platform, it's not that easy, because as mentioned, the reflection part is really limited in the Commons project, so we cannot do that. That's why we need to, at least from what I understand, move it down there and then inject it and have a no arguments constructor. But yeah, as mentioned or as shown, so currently I don't use any dependency injection, which again has the benefit that it's that there's no magic happening, and you really define here or describe directly what you want to have. The downside, of course, is so whenever you change something in your arguments or in your constructor, you also need to come back to your configuration and fix it there as well, which might not be a big problem, because usually you might have only one or two bigger world configurations in your application, and the compiler will anyway complain when something is here not matching, and then you simply pass your things. Another thing, if we want to keep the dependency injection, so this is open for discussion, we could do that, and there I thought of maybe simply have another block. So for example, injectables, and there you add then your different things there, and down in the systems you would then not, of course, create the systems here directly. It would be then similar to the components that you provide a system factory, will be most likely a no arguments factory like that, and then Fleks in the background then uses these injectables to add the things that you need, as I've shown it before. So those are my two questions. So the first one, the family configuration, should it be a separate function, or do we pass it as constructor argument? And the second thing, do we want to keep dependency injection or not? My personal preference would be we don't use dependency injection, because again, I think it's easier and has the learning curve then of using Fleks is pretty low, because it's basically normal Kotlin stuff, so nothing fancy there. And if you want to use dependency injection, you could still use another library, like for example Coin, or I think for libgdx, so the libktx extension, they also have a dependency injection module from what I know. Then it would be up to the user to use that, and it would be optional. And for the family stuff, I personally tend towards a separate function instead of constructor argument. And that would be it. Yeah, so not a lot happened other than that. So I was playing around a little bit with the DSL, did not have a lot of time, but now I should have more time in the future. So now it looks a little bit better. And also end of April, beginning of May, we can start, or I want to do another small libgdx tutorial. A few people ask about that I go into detail about certain things, and the current idea would be to work on a small box2D project, so to show you how the physics engine works there and how to use that together with entities, and also the AI part that I used in Quilly Crawler and Quilly Jumper, so that you see, for example, how you can create your own enemies, which work a little bit smart and do certain things that you would expect from an AI. So maybe there we write a small game. That would be my idea. Okay, with that, that's it. I wish you happy Easter, because the Easter weekend is now in Austria. And I don't know where you are. Maybe you also have Easter holidays. So happy Easter and have a nice weekend. And bye-bye.